Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.48. While solving this problem, we will be using current divider rule. Basic questions for the calculation of current I1 and I2 using current divider rule for this particular circuit is provided here. We also will be using parallel equivalent resistance calculation formula for two parallel connected resistances. That is, R equivalent equal to the product of both resistances connected in parallel connection divided by their sum. Now move towards the problem. Exercise problem number 2.48. Find I0 in given below figure. This is the circuit diagram of given problem. We have to find the value of current I0 inside this branch. There are multiple methods to solve this problem, but we will adopt current divider rule to solve this problem. That is the easiest way to calculate current I0 inside this network. Right now you may see that this circuit includes three parallel connected resistances. But we are interested to calculate the current of this resistance only. So we will try to simplify this circuit by taking the equivalent resistance of these two parallel connected resistances. In that case only we will be able to apply current divider rule on this circuit. So first we will try to find out the equivalent resistance of these two parallel connected resistances, 12 kilo ohm and 6 kilo ohm. For that purpose, we will use equivalent resistance calculation formula for two parallel connected resistances. R equivalent is calculated by taking the product of both parallel connected resistances dividing by their sum. In our case, R1 is 6 kilo ohm and R2 is 12 kilo ohm. So place the values of R1 and R2 inside this equation. R equivalent will be equal to the product of both resistances R1 and R2 divided by their sum. Product of 6K and 12K will become 72K and sum of 6K and 12K will become 18K. Now divide 72K on 18K, the answer will be 4K. So the equivalent resistance of these two parallel connected resistances is 4 kilo ohm. We can replace both of these resistances with a single resistance having the value of 4 kilo ohm. So modify the circuit according to the calculated equivalent resistance. Now the circuit is simplified. We can apply current divider rule on this circuit to calculate the value of current I0. Before that, we have to nominate the branch currents. This branch current will be labeled as I1 and this branch current will be labeled as I2. We are interested to calculate the value of I1 that is equal to I0 because of same branch. So using current divider rule, the equation for the calculation of current I1 will be I1 is equal to R2 divided by R1 plus R2 multiplied by I into T. Here in this equation, I into T is the total supplied current. In our case, it is 12 milliampere. R2 is 4 kilo ohm and R1 is 12 kilo ohm. Place values inside this equation to calculate the value of I0. That will become R2 is 4 kilo ohm and R1 is 12 kilo ohm plus R2 4 kilo ohm multiplied by total supplied current 12 milliampere. Now solve this equation, take the sum of 12K and 4K, it will become 16K. Now cancel out 16K with 4K, the equation will become 1 divided by 4 multiplied by 12 milliampere. Divide 12 milliampere by 4, the answer will be minus 3 milliampere. Here I have taken minus sign along with the value of I0 because this current is entering on this node and it will leave to these two branches. So the direction of current inside this branch will be upward. But the direction of current I0 is downward, which is opposite to the actual direction of current. That's why we have taken minus sign along with the value of current I0. So the value of current I0 inside this network is minus 3 milliampere. This was exercise problem number 2.48. Thank you. See you again in next video.